So in this opportunity to practice, the question is a definite integral, and the argument is the logarithm of x, the natural logarithm, so logarithm to the base e. And again, try it, and afterwards I will give you the solution and a couple of comments. So I will stop now and come back in a minute and have a go at it, please, with pen and paper. Okay, welcome back. The solution is on the next slide. So the integral of the natural logarithm is a classic problem in calculus, and when we look at this, we might not think initially to use integration by parts, but the pattern that we need to realize, because this applies to more than just the logarithm, is that this is a function that you know how to differentiate. The derivative of log of x is 1 over x, and if you don't know how to integrate it, you can use integration by parts. And parts means that you have to write the integrand as a product, and here we've just got log of x, but you can always write anything as 1 times itself. The integration by parts formula is here. On the next slide, at the very end of this short video, I will give you the derivation of this formula. And we have to decide what we're going to differentiate and what we're going to integrate. So u will be differentiated, v prime will be integrated. Now, clearly, we are not going to integrate the log, because if we could just do it, we would not waste our time using integration by parts. So we're going to differentiate the logarithm, so that's going to be our choice of u, and u dash is going to be 1 over x, and v dash is going to be 1, and then when we integrate it, we will get x. And because we are increasing the power of x, we might be a little bit worried, but the derivative of the logarithm is 1 over x, so everything will be fine. So this is our integral, and we have, first of all, u times v, and everything is written here for us. So it's log of x times x, and I'm just putting them in what I think is a more helpful order, x times log of x. And this is evaluated between the lower limit and the upper limit. And then we subtract the new integral, which is the integral, again, from 1 over e to 1, of the derivative of u, that's 1 over x, multiplied by the integral of v dash, and that's just x. So we see that these factors of x are just going to cancel, and we are going to just have a 1 in a moment to integrate. So we expand this, so at the upper limit, which we look at first, it's 1 times the log of 1, and that's that, and that's going to vanish because the logarithm of 1 is 0, so that will vanish because e to the naught is 1, anything to the naught is 1, and then we subtract this evaluated at the lower limit, so 1 over e times the log of 1 over e. And then we subtract, we've worked this out now, these two terms, and then we subtract here this integral, and it's just the integral of 1 with respect to x. So what is this logarithm? Well, 1 over e means e to the minus 1, so we have the log of e to the minus 1, and that logarithm is therefore just minus 1. There's a minus sign there already, so we are going to have a plus sign, plus 1 over e from this term here. And then we subtract this integral. Now the integral of 1 is just x, and that's between these limits. So what we have in total is 1 over e minus, and now we've got a minus sign outside of this. This is going to be a difference. So I think the very first character you should write after the minus sign is a big brackets. And then at the upper limit we have 1, and then we subtract, and at the lower limit it's 1 over e. Close our brackets. So now we expand. 1 over e minus 1 minus minus is plus 1 over e. So these two terms add together, we get 2 over e minus 1. Now, in a definite integral, when you look at the result, it's often not obvious whether it's correct or wrong, and you can look at things like trying to bound the integral. But one of the very simple things you can sometimes do is just to say, well, I expect this to be positive or this to be negative. And I will explain on the next slide why we would expect this to be negative. But let's just see here that it is negative. E is a number, approximately 2.7, 2.718, etc. So 2 divided by e is less than 1. And then if we subtract 1 from it, our overall result is going to be negative. So once we realise that, this gives us, I hope, some confidence that we actually have obtained the correct result, and that the integral from 1 over e to 1 of the logarithm of x with respect to x is indeed 2 over e minus 1. And that is our final answer. So again, just to summarise, to calculate this integral, we thought, well, we know how to differentiate it. We can't see anything else that jumps out at us. So we rewrite the integrand as 1 times that function. We use integration by parts. It's helpful if you're using it to write the formula out, to write out what your choice of u and v prime are, and then immediately to differentiate u and integrate v prime, because then here you've got written out explicitly everything you need to be put into this formula. So it makes life much easier if you get into that habit. So this is our integral from this term, and as a definite integral it's evaluated between the lower and upper limits. This is what we had, and then this is the additional integral that we get. So the whole point of parts is that you're turning one integral into some algebra and another integral that you are hoping is going to make life better for you. And in this case, it made life better for us because it just turned into the integral of 1. And then finally, after we'd calculated this definite integral, we thought, well, our answer is negative and we expect that. So let's see why we expect it on the next slide. So I've said that we expect this integral to be negative. Why? So the thing to do is you look at the graph of the integrand. So our integrand is the natural logarithm of x, log of x, and it's being integrated from 1 over e to 1. And remember, the logarithm of 1 is 0. So it's crossing the x-axis at x is 1, y is 0. And if you are less than 1, the logarithm is negative. And this area between the curve and the x-axis, between x is 1 over e and x is 1, is all below the x-axis. So the value of the logarithm is going to be equal to this area multiplied by a minus sign. So we expect the answer to be negative, and our answer of 2 over e minus 1 is plausible. And quickly, just to finish off this podcast, this video, what I want to do is just to derive the integration by parts formula, and it follows from the product rule. All of the methods of integration essentially follow from methods of differentiation. So this is the product rule in the way that I like to write it, in this ordering. And if I just take this term over to this side, and I also swap the sides around, I will have u dash v is equal to the derivative of u times v, and then minus u times v dash. And now, if we integrate both sides, so we integrate this side, we're going to get here the integral of a derivative, and the integral of a derivative is just whatever the function is, up to an integration constant, minus the integral of this function here. So this is defined only up to an integration constant, and this is defined only up to an integration constant, so I don't think that there is any need whatsoever to write plus c or something here. The integration constant ambiguity is present on both sides. So on this side, we've just tried to understand why we expect this integral to be negative, and just very rapidly derive the integration by parts formula. And with that, I'll stop this video.